Okay guys, so in this video we're going to talk about some more advanced math stuff. And one thing I wanted to bring your attention to that I attached to this post was the quick reference guide. So if you could take a look at the quick reference guide, click on that link, I'll bring mine up. This guide is something we're going to use throughout the year. You're allowed to use it on all parts of the AP test. We'll refer to it constantly. You do not need to or want to memorize anything on here. I mean, you will, but everything is on here for you to look at. A lot of this doesn't make sense right now. That's totally fine. But let's scroll down to where it says the math class. So it's the second one from the bottom. Okay, now in the math class, it gives you these little like lines code. I want you to right now ignore the static and the int or the static and the double. That doesn't mean anything now, it will later. We're just going to look at the word for the parentheses. This is abs int x. So it's telling you if you send some integer to this abs bit of code, it'll give you the abs value. If you send a double, it'll give you the abs value. And then there's one for powers, for math.pow, and then for Sqrt, that'll give you the square root of any double that you send it right there. Okay, so these are just different methods to take absolute value, the power, and the Sqrt. They're in the math class, so the way we're going to call it is through the name of that class. Someone wrote a public class math somewhere, we're going to access it. So to get the absolute value, we're going to use math.abs. And you can put this in a print line statement. So if you just want to get the absolute value of, I don't know, -7, you could just do it like that, and it'll give it to you. You could also store it as a variable. So I can say num1 is, I don't know, 65. And then I could make another one. So I could do int abs num1 would be math.abs of num1. Okay. So I can send it a variable here. I can put a number in there. It just has to have an integer or a double in parentheses. Okay, so then when I go ahead and print that out, the absolute value of num is 1, so that should be 65, and of course the absolute value of -7 should be 7. And when I compile my code and run my code, that's exactly what we see. Okay, cool. The next thing on here is pow. So you might want to use exponents, right? If you had something squared, you could do like, 4 or x times x instead of x squared, but what if you want like a bigger exponent? Okay, so or a fractional exponent or something. For exponents, you're going to use math.pow, and this will always give you a decimal. Okay, and for the same thing, you could do math.pow, say, I don't know, like, what is 2 to the 10th power? And some of you might not know this is 1024, but oh yeah, I also did that wrong. I forgot to actually write math.pow. Okay, and then we write math.pow and in parentheses, and they kind of like give you this right here. They tell you that in the parentheses, you have to put two numbers, the base and then the exponent. And they'll accept either doubles or ints because 2 is obviously like 2.0. You can store it as a double. So it'll do 2 to the 10th power, which should be 1024, and that's what it gives me. Okay, and it also works for fractional exponents or negative exponents or that sort of thing. So I could store, for example, like, I don't know, double 1/4. So I could store math.pow. I could do 2 to the power of, let's see, -2. So that'd be 1/2 squared, which should be that. And then I can print out that variable. So, oops. I gotta actually write the name of the variable here. Great job. Okay, so when I do that, again, it'll give me the decimal. 1/4 is 0.25. Okay, so that's how you can write kind of some exponents. And it works. You could do like some weird exponent too. You do like the 5.1 power, which is a little bigger than 2 to the 5th, so 33 or 34 point something. Yeah, there you go. Okay, so that'll work for all sorts of things. This is a very powerful tool. One thing I did want to point out is it must be saved as a double. So if you try and do like even something that you know is an integer, so int num2 would be math.pow like 3, 4. Like 3 to the 4th power is obviously going to be an integer, but Java doesn't know that, so it'll tell you in a lossy conversion from a double to an int. You just got to save your variable as a double instead of an int. Okay, so that's how math.pow works. The only other thing I wanted here is math.sqrt. Same thing. Inside the parentheses, you'll put any one number. With math.pow, you had to put the base, comma, the exponent. And with Sqrt, you just put in any number, and it'll give you the square root. So again, you can do this with variables or print lines or whatever, but if you just do math.sqrt of, I don't know, 16, the square root of 16, of course, is 4, and it'll give you 4.0 probably, maybe exactly 4. Yeah, 4.0. Okay. You could give it some weird number, 17, and of course, it'll just give you some bizarre decimal. So if you need to take a square root, like to do Pythagorean theorem or something, this is how you would go about doing it. Okay, So that's the exciting part there with math.path. Next thing I wanted to take a look at was just some weird things. So here's kind of an interesting property of integers. So integers can get a little bit weird. So let me just give you an example. Let's say I take two pretty big numbers. So let's say I take 1,000,000. And then I'm going to multiply that by, I don't know, 1,000,000 again. So this should be 1,000,000 times 1,000,000, by the way, should be 1,000,000,000,000. But what we see, I'm going to call this big because I think we already have enough. What we're going to see is when you try and print this out, something weird actually happens. So when I try and print it out, it should give me 1,000,000,000,000, and it gave me, looks like, negative 727,000,000. All right, so that's a little bit off. It's not actually exactly what we expected. Yeah, so you can get a little weird with big, like very big or very negative numbers. And basically what happens here is there's some maximum value. It's a little over 2 billion. That's actually 2 to the 31st power minus 1. But there's some maximum value that you cannot get above. And once you get above that number, Java, what it does is it kind of actually rolls over to the smallest possible number. So let me show you, for instance, here's like the biggest number you can get. I wrote this down. So it is 2,147,483,647. Okay. And then maybe you want to add 1 to it. So we can just take it to be whatever it was before plus 1. Okay. So that'll just set it to be its previous value plus 1. But now when we go ahead and print it out, we're going to see that it actually has turned into a negative number, which is pretty amazing, right? You add 2 billion, or you have 2 billion, you add 1, and you get a negative number. Incredible. Well, math isn't broken. This is just a limitation of Java. And what happens here is when you get all the way to the top, to the very biggest number, it just wraps around and goes to the smallest possible number. So if you were to add 1 again, you'll see it work correctly. It just got to like the biggest possible number and then wrapped around. And we'll see this, like it actually did add 1 correctly the second time, so that's kind of nice. This is pretty weird. Basically, when you get to the biggest possible number, Java wraps around to the negative. And then it just keeps going, and it wraps around, and keeps going, wraps around, and keeps going. This is not actually going to come into play most of the time, and you don't need to worry too much about this. I want to show you because it exists. But if you actually want to see the biggest and smallest numbers, they're actually on the quick reference guide. So instead of memorizing the number, you just kind of take this code off the quick reference guide. It's under the integer, so integer.minValue and integer.maxValue. And you could just put this code inside a print line or declare it with a variable or whatever. So if you want to see the largest numbers, you just print out integer.max_value. Okay. And again, not something you need to memorize. You'll just do that. And then if you want to see the smallest possible number, same thing, just min. These are actually going to be useful to us later in this semester. For now, it's just kind of a for fun thing, something to be aware of that happens. Okay. So that was the main thing I wanted to share with you today. I hope this was helpful. I hope this was interesting, learning a little bit about numbers in Java. And I'll see you guys soon. I think you guys are going to have fun on these labs.